So consider this problem statement. If m is chosen in the quadratic equation, that is m square plus 1 times x square minus 3x plus m square plus 1 whole squared, that is equal to 0, such that the sum of its roots is greatest, and if the absolute difference of the cubes of its roots is k, in that case we need to compute the value of square root of 5 times k. So definitely this k is outside, right? Fine. So now let us proceed towards the solution. Now here, this is the given equation, right? This one is our given equation. So let me mark this one as equation 1, right? So if I say that the roots of the equation, let's say it is alpha and beta, instead of writing alpha and beta, I'll write a and b, right? So I'll say let the roots of the equation 1 are this a and then comma b. So you can also take alpha and beta for representational aspect. So in that case we can say that the sum of roots, that is a plus b, that will be equal to 3 over, this will be 3x, right? So 3 over m square plus 1, m square plus 1, and the product of the roots, that will be a times b, that will be equal to m square plus 1. So you can observe, when you divide this m square plus 1 whole square over m square plus 1, so the remaining term is m square plus 1 end of the day, right? So according to the problem statement, now here we'll go ahead and we'll write according to the problem statement. So it says that the sum of roots, is greatest, that means this is the largest actually, and it is possible, in which case, think about it, it is possible only when my this m square plus 1 is minimum, only when this m square plus 1. So you can observe here that if in this, if you observe this a plus b is equal to 3 over m square plus 1, if this is minimum, if this will take the minimum value, so on substituting m as 0, the minimum, that will be this entire value will be 1. So if I deviate any value from 1, if I deviate from 1, then this value will effectively reduce, because the denominator, as long as the denominator is 1, the value remains 3. If you deviate for any other number for this denominator, right, like instead of this m, if I put 0, then this is 1. If I put any other number apart from 0, in that case the denominator will increase, and if the denominator increases, the overall value will fall down, right? So it is possible only when m square plus 1 is minimum, and I can say very well that minimum of m square plus 1, if I talk about in terms of real numbers, it is only possible when my m has to be 0. So in this case the m has to be 0, then only we can get this 1, and then this value will remain 3. So the largest value for this expression we can achieve is 3, and we cannot go larger than that. So for that m has to be 0. So we got this value. So from this we can say, that therefore for this, the sum of roots, so instead of m I will substitute here 0. So this effectively becomes 3, and the product, that is a times b, that is m square plus 1, that is equal to 0 plus 1. So a times b, that is equal to 1 over here. Now the next given information about this problem statement is the absolute difference of the cubes of the roots, right? So I'll have to use this one. So now let us use this particular language. So it says that now the absolute, so let me just take one line of space over here, blank line, absolute difference of the cubes of the roots. So that can be represented as absolute value function, and here a cube minus b cube. Now I will be using the identity over here, that is absolute value. Within this we can write a minus b, and in the product I can write a square plus b square plus ab, right? Now this a minus b can be written as square root of a plus b whole squared minus 4 times ab. This is one thing, times, and then within the absolute value of this we can write this one as a plus b whole squared minus ab, right? So now let us make the appropriate substitutions, right? So here if I make the appropriate substitution, that is a plus b given as 3 square 3, so this is 3 squared, ab is given 1, so 9 minus 4, that is square root of 5 again, and here this will be, that is 3 squared, that is 9, and ab is 1. So finally we can observe here this can be written as square root of 5 times, and here this is 4, this is 3 square minus 9, that is 8, so 8 times square root of 5. Now in the problem statement they are asking that we need to compute the value square root of 5 times k. So now this will be our final answer. So therefore this will be equal to k. The value of k is given as, this is actually equal to k, right? So 8 times square root of 5. So if I multiply with this, so we'll get 8 times 5, that is 40. So for this 40 is the, for this problem statement 40 is the answer, right? So this is the problem statement and this is the solution, and we have the answer as 40.